Good day, everyone. So for these lessons, we're going to have a lessons on hypothesis testing. So this is actually a hypothesis testing about one population group. So we want to find out whether, based from a sample, whether the observed values based on the mean is significant at a certain level. But before we proceed to what is actually the hypothesis testing, so this is not new to you because you already have this as your separate subjects during your senior high. Now, if you're going to compare the formula in the confidence interval for one population mean with a 95% confidence, so for us now to find the confidence intervals of a population parameter based from a sample mean, then we have the sample mean plus and minus, then our margin of error with the critical value of 1.96 because we want 95% confidence multiplied to the standard error of the mean, which is the standard deviations divided by the square root of the mean. Now, if you're going to look this into the formula for the hypothesis testing for one population mean at 5% level, so you notice class that the 5% level is the complement of the 95% confidence. So this is actually a sort of an error, okay? We call this now the alpha error. And this is given by the formula to solve whether or not our hypothesized value is significant or not. So we have this formula based on the t. Then we have to take the difference of the sample mean minus the hypothesized mean that we want to find out whether or not this is significant. The difference is significant. Then again, we divide it by the standard error of the mean. Our basis class for rejecting our hypothesis, especially the null hypothesis, is if the computed t-value, okay, the absolute, meaning we disregard if there is a negative, is greater than the 1.96. If the t-value is less than the negative 1.96, then we know that we are going to reject the null hypothesis. So the formula can be rewritten also in this manner. Okay, so if you want to put the square root of your n on the numerator, you can do that, but most often than not, we use the original formula. So where you need the following when you read the problem class or when you identify the given conditions, you need to find out what is the sample size, that is your n, what is the sample standard deviation. If the standard deviation is not given, if the variance is given, then you know that you're going to take the square root of the variance. The result is the standard deviation. Of course, the sample mean that is given and the population mean, this is usually the hypothesized value. This is the value where the claim is typically used. Okay, and we know that this is our hypothesized mean. So we want to find out whether the difference between the sample mean and the population mean that we hypothesized is significant enough at a certain level. Now, testing a claim about a population. So, of course, nowadays we use the p-values that will automatically provide the value whether or not it is significant. Okay, if technology is not available, then we can still use the critical values, and we only use these two. If we want 5%, okay, level, then our critical value is the plus and minus 1.96. If the critical value is 2.575, then we want it to be 1% level. Okay, so we are just going to use the total test because there are others that we can use the left tail or the right tail. So for simplicity, we just focus on the two tails. So we have to use one positive and one negative critical values. So again, so for us now to find out whether or not our computed t-value is significant or not, so we always use this as our guide. So this is our graph usually as part of the solution. Now we put here the negative and the positive critical values depends on what level. So remember, there are only two. We have the 1.96 and the 2.575. Now, if the computed t-value class is within this region of non-rejections, in other words, it is between the negative and positive critical values, then our decision was do not reject the null hypothesis. Then the conclusion now is the statement in the null hypothesis. However, if the computed t-value is outside the non-critical region, in other words, it is either less than the negative critical region or above or more than the positive critical region, so these are the critical regions outside, it means class that we have to reject the null hypothesis, and the conclusion will be the statement in the alternative hypothesis. Okay, so since this is a hypothesis testing class in one group, then we have to go with the process of hypothesis testing. So there are several steps, but as much as we can only use the shortest way possible. Okay, so let's have here the first example. Okay, now college students evaluate their instructors from 1 being poor to 5 being excellent on how effective their instructors in delivering the lesson. So you always do this every semester. So a sample of 193 were randomly selected. So these are the 193 students perhaps that they uh, evaluate their instructors, and found that the sample mean rating is 3.91 with a standard deviation of 0.53. Then use a zero point zero 0.05 significance level to test the claim that the population of student faculty evaluations has a mean equal to 4.00. So what we're going to do here is to identify the given data. Okay, so we have a sample of 193. This is the mean sample of 3.91 based from the sample of 193 with a standard deviation of 0.53. Then we are asked to find whether or not it is significant at 5% or 0.05 that the sample value that we had, 3.91, is different from 4.00 as the hypothesized mean value. Okay, so once we identify the needed data, then we can now formally state our null and alternative hypothesis, because it's important class that when we have a conclusion later on, which of these two conclusions is the correct. The claim is that the population of the student faculty evaluations has a mean equals to 4.00. So this is part of the problem given. So we identify the claim class whether it is a null hypothesis or an alternative hypothesis. Now, because the given claim class has an idea of equality, or it has a condition that it is equals, then any statement class with equality is actually the null hypothesis. Okay, so that's always the case. So therefore, the null hypothesis would be the population of the students' faculty evaluations has a mean equals to 4.00. So this is the claim class, and the alternative class is the opposite. So whatever is the statement in the null, then you have to rewrite it the opposite, and that will be your alternative. So the alternative hypothesis would be the population of student faculty evaluations has a mean not equals to 4.00. The reason why we have these two opposing statements class because one of these is true and one is not true. Now take note that regardless of the claim, always look for equality. Okay, so the equality is always the null hypothesis. Then if the claim is the alternative, then we have to rewrite it in such a way it will contain the equality concept class. Okay, so we are now ready to solve for the t-value. So going back to the data that we gathered, okay, so we have a 193 sample size. The mean, okay, evaluation is 3.91 with the standard deviations of 0.53, and the hypothesized mean is 4.00. Then we use the formula given. Okay, so as I said, you have to choose, but usually I use the original one. Then we plug in all the values. Okay, then we round our answers to 3 decimal places. Now, plugging all the values, then simplify. So typically class in your denominator, so you will have a value that is a non-terminating decimal. All you have to do, class, is round your answers up to 4 decimal places. The reason is for accuracy. So then you divide, you take the ratio, then your final answer should be up to 3 decimal places, okay, for consistency. So in this case, class, this is already the computed t-value of negative 2.356. The negative, class, indicates that the 3.91 is in fact less than the 4. So this is very important later on if you want to further uh, the explanations of your conclusions. So the next now, because we are given 0.05 as the level, okay, of significance, so we have to choose now your positive and negative 1.96. So we have to put the critical values negative 1.96 and positive 1.96, okay, as a demarcation so that we can put where the computed t-value. So our t-value, class, is negative 2.356, which is somewhere here, which is less than the negative 1.96 as a critical value. So we can easily see our decision, class, that because the t-value is negative 2.356, which is less than the negative 1.96, or it is within the critical region, so we can say that the decision would be we have to reject the null hypothesis because the computed value of your t is within the critical region. So as we rejected the null hypothesis, class, remember that the conclusion is the statement in the alternative. That's the reason why, class, you have to reject the null hypothesis. It means that the correct hypothesis is the alternative hypothesis. So therefore, our conclusions would be at 5% level, the population student faculty evaluations has a mean not equals to 4.00. In other words, class, it is in fact less than positive 4 yung the evaluations. Okay, so if you're going now uh, to say now that we hypothesize that when students evaluate their teachers, so it is within the range of 4.00. In fact, in our sample size of 193, it is less than 4, it is 3.91. So the negative t-value indicates that the true mean evaluation score is less than 4. So that's the conclusion, class. So that's how we test hypothesis, class, using one population mean. So another example is this one, class. Okay, so you have to be very analytical about the uh, hypothesis testing, class. So familiarized with the data, what are the things that we are going to identify, okay, then how we are going now to identify the claim, whether it is a null or alternative, then we go again the process of hypothesis testing. So we have here a second example. So in a test of effectiveness of garlic for lowering cholesterol, 149 subjects were treated with raw garlic. So either they eat it, so we do not know how they consume the raw garlic. Now, cholesterol levels were measured before and after the treatment. So this is how it is done. So before taking the raw garlic, their cholesterol is being measured. Then they consume the raw garlic. Then after the treatment, again, their cholesterol levels is again measured. So there is no the difference. Now, if the difference is 0, it means that there is no change. If the difference is negative, it means that there is a decrease. If the difference is positive, it means that there is an increase. So the changes before minus after in their levels of the LDL cholesterol have a mean of 0.4. In other words, it is not exactly equals to 0. So there is now a difference that the cholesterol level before is greater than the cholesterol level after. So it has a positive difference with a standard deviation of 21. So there's a very big standard deviations. Then we use zero point zero 0.01 significance level to test the claim. So again, you have to identify what is the claim. That with garlic treatment, the mean change in LDL cholesterol is not equals to 0. It means that is zero point 0.4 is not equals to 0. Literally speaking, class, yes. zero point 0.4 is not equals to 0, but in statistics, in hypothesis testing, so we have to show them that zero point 0.4 is not really equals to 0, because if it is equals to 0, the reason why, because due to sampling error. But if zero point 0.4 is not really equals to 0, then we could say that zero point 0.4 is really different. Then, what do the results suggest about the effectiveness of the garlic treatment? So again, identify the data. Okay, so we have 149 subjects. Then the mean based from the 149 is zero point 0.4 with a standard deviation of 21. At a 1% level of significance, we are going to test the claim that it is simply equals to 0. So this is our hypothesized value. So identifying our set of data class. So this is important because these are part of your values that we need to input in the formula later on. So once we identify the given data, then we can now formally establish our null and alternative hypothesis. So going back to the claim is that the mean change is not equals to 0. So there is now the not equals. So this means that the claim is the alternative hypothesis. So if you're going to rewrite the null in the alternative, so the claim now becomes your alternative hypothesis. Then you have to rewrite your null hypothesis, which is the opposite. So with the garlic treatment, the mean change in LDL cholesterol is equals to 0. So this is your null hypothesis. The claim becomes your alternative because the mean change in LDL cholesterol is not equals to 0. So we want to find out, class, whether zero point 0.4 against 0 is different or not. Now, in hypothesis testing, class, what we are testing is the null hypothesis, not the alternative. Okay. So we already have our null and alternative hypothesis. So we are now ready to solve for our t-value. All we do, class, is substitute these four data that we identify in the problem. Substitute this into the formula. As I said, always round your answers in the denominator up to 4 decimal places. Then the final answer should be 3 decimal places. So here, the difference of zero point 0.4 and 0 is still zero point 0.4, so we want to find out whether the difference of zero point 0.4 is significant or not. Of course, the divisor is your standard error. Then the result is 0.332, 0.233. So we have to plot this into our graph. And of course, we identify first what is the critical value. So because we are given that it is 0.01 or 1% level of significance, so our critical value class should be positive and negative 2.575. So that's the one that we are going to put here as a demarcations. Then we plot where is the computed t value located. So the computed t value located, class, is somewhere here. Okay, not really accurate na yan, but we know that it is between your critical values. Then we know already what to do. Okay, so our decision, we see here that we have to uh, do not reject the null hypothesis. So our decision now is do not reject the null hypothesis because the computed t-value is not within the critical region. So if we do not reject the null hypothesis, so our conclusion is the statement in the null hypothesis because we did not reject it, class. So therefore, at 1% level, with garlic treatment, the mean change in LDL cholesterol is equals to 0. In other words, class, the zero point 0.4 sample mean is actually the same as your 0. So they are not really different. So this gives us an idea, class, that eating garlic does not change the LDL cholesterol level. So the implication is that is it effective or not effective? So that's the another question. So what do the results suggest about the effectiveness of the garlic treatment? Because our conclusion is that it is still equals to 0, there is no change in the cholesterol level before and after taking the garlic, then it means that it is not effective. So, effectiveness of the garlic for lowering cholesterol is not effective because it is not significant class at 1%. So, this is how we solve, okay, hypothesis testing. So, we always follow, okay, some uh, not rules class but steps. Okay, first is that identify the needed information. Second, you're going to establish the null and alternative hypothesis. Then you are going to solve for the t-value. Then you are going to compare the computed t-value against the critical value, depends on the level of significance given. Then that's where you can now uh, decide whether you are going to reject the null hypothesis or do not reject the null hypothesis. Then when you reject the null hypothesis class, then your conclusion is the statement in the alternative hypothesis. If you did not reject the null hypothesis, your conclusion is the statement in the null hypothesis. Okay, so I hope you learned something from today's presentation class. And once again, thank you. Then I will see you again on the next lesson. So this is the next lesson class will be the hypothesis testing on population proportion. Thank you.